In the last section, you saw that you can write any complex number in modulus argument form. All you need to do is work out the modulus and the argument of the complex number and then write it in this form: r cos theta plus I sine of theta, where r is the modulus and theta is the argument of the complex number. Well, that might seem like quite a random thing to do, but it turns out that writing a complex number in modulus argument form is a really useful method with lots of applications. And in fact, in the next textbook in further maths, you're going to look at lots of applications of complex numbers which require the modulus argument form. In this chapter, we're going to look at how to times and divide complex numbers really easily when they're written in modulus argument form. Let's say that we've got these two complex numbers, z1 and z2, and we want to times them together or divide them. You've already seen how to do that, the method used so far. To times them together, you would just multiply out this double bracket and simplify. And to divide them, you would times the top and the bottom of this fraction by the complex conjugate of the denominator. And that would make sure that we get a real number on the denominator so we can simplify the fraction. And what we're going to do now is we're going to look at a different method which uses modulus argument forms. So before we do that, what we want is we want to start with two general complex numbers in modulus argument form. Let's say z1 is, has modulus r1 and argument theta 1. And another complex number, let's say z2 with modulus r2 and argument theta 2. And what we want to do is we want to come up with a general formula which says, how do you times these two complex numbers together? So let's try and work out where that formula comes from. So let's do z1 multiplied by z2. So we're going to do this complex number multiplied by this other complex number here. And hopefully we'll be able to simplify it into a nice easy formula which makes multiplying complex numbers easier. So I'm going to start off by doing r1 times r2 and just put that at the front. And then I'm going to multiply out this double bracket. So we've got cos theta 1, cos theta 2, plus I sine theta 2, cos theta 1, plus I sine theta 1, cos theta 2, and then finally we've got I sine theta 1 times I sine theta 2, so we're going to have plus I squared sine theta 1 sine theta 2. Well, this formula is not looking very nice so far to try and work out what z1 and z2 are, so let's try and simplify what's inside that square bracket. So I'm going to try and collect together the real parts inside this bracket and the imaginary parts. Well, this is real because it's not got an I in it. And also I know that I squared is equal to minus 1. So this term here is actually real as well. So we've got cos theta 1, cos theta 2, and then replacing I squared with minus 1, we're going to have minus sine theta 1 sine theta 2. So that's the purple terms collected together, the real terms. The imaginary terms are these two green terms here, and I'm going to take I outside of a bracket like we often do. So we're going to have I lots of sine theta 2 cos theta 1 plus sine theta 1 cos theta 2. Okay, so still this formula is not looking very nice. I don't want to have to try and remember this formula. It doesn't look like we've simplified it. But you'll notice that actually this looks like the double angle formula or the compound angle formula for cos. Remember that we know that cos of A plus B is cos of A, cos of B minus sine of A, sine of B. So here we've got A is theta 1 and B is theta 2. So if you want, you could write it underneath theta 1 plus theta 2. Replace a with theta 1. We've got cos theta 1. Replace b with theta 2. So we can replace these terms here at the start of this bracket with cos of theta 1 plus theta 2. Okay, so that's nice and simple. Let's see if we can simplify this part inside this round bracket here. So we've got sine cos plus sine cos. Actually, that looks a lot like if we've got sine of a plus b, we know that's equal to sine a cos b minus sine b cos a. So here we've got a is theta 2 and b is theta 1. So we've got sine of theta 2 cos of theta 1, that's that part there. And sorry, this should be a plus. Plus sine of theta 1 cos of theta 2. Okay, so that's good. We can replace this bracket here with sine of theta 1 plus theta 2. So that's a really nice formula. So that means that if we've got two complex numbers written in modulus argument form like that, then we can jump straight away to the multiplication just using this formula. Now notice that this actually is a number that's in modulus argument form. You can see that this is the modulus, the part outside the bracket of the complex number, and this part here inside the brackets of sine and cos is the argument. So this thing here is the modulus of z1 times z2, and this here inside the bracket is the argument of z1 times z2. So that gives us a formula which tells you that if you want to work out the modulus of z1 times z2, all you need to do is multiply together the modulus of z1 and the modulus of z2, because we've got r1, sorry, that should be r2, r1, r2 at the front. And another useful formula is that if you want to work out the argument of z1 times z2, you're going to do the argument of z1 plus the argument of z2. So that's going to be argument of z1 plus the argument of z2. But really the most useful formula is this one here, which says that if you can work out z1 and z2 using this formula here. So let's look at this specific example. So I said that there was another method of timesing these two complex numbers together, and that method is going to be to write them in modulus argument form. Well, I've already worked that out. I know that z1 has modulus 2 and argument pi over 4. So we can write z1 in this form here. And similarly, we can write z2. The modulus of z2 is 4, and the argument of z2 is 2 pi over 3. So that means that we can write z2 in this form here. So I promised a quick way of timesing these two complex numbers together. Well, all we need to do is remember that the modulus of the product is going to be the modulus of the first complex number times by the modulus of the second complex number. So in this case, it's going to be 2 times by 4, which is going to be 8. And we need to work out what the argument of this new complex number is when we times the two together. Well, we're just going to add together the arguments. Here we did theta 1 add theta 2. So we're going to do pi over 4 plus 2 pi over 3. So if we work that out, we'd get 8 cos of 11 twelfths pi plus I sine of 11 twelfths of pi. So our product, the complex number which is the product, has modulus 8 and argument 11 over 12 pi. So if we were to look at this geometrically, I've put Z1 and Z2 on an Argand diagram. In order to multiply these two complex numbers together, we've got a new complex number which is 8 away from the origin. So further away from the origin, it's out there. We've done 2, the modulus of that one, times by the modulus of that one to get 8. And the argument is going to be all of this angle here. And to get that angle, we did the modulus of the first complex number, pi over 4, add the modulus of the other complex number, 2 pi over 3. And we ended up over here at an angle of 11 twelfths pi. We could do a very similar thing to come up with a formula of how to do Z1 divided by Z2 to divide two complex numbers. I'm not going to go through the whole process of deriving this, but you can have a go at it if you want by trying to copy what we did here when we times the two together. But the formula for this is going to be the modulus of this complex number is going to be R1 divided by R2. So we divide the moduluses of complex numbers. And the argument of the division is going to be the argument of the first complex number subtract the argument of the second complex number. Okay. So in this case, if we wanted to quickly work out Z1 divided by Z2, we're going to do the modulus of Z1 divided by the modulus of Z2, and that's going to be the modulus of our complex number. And to work out the argument of the answer, or of this fraction, we're going to subtract the arguments. So we're going to do the argument of Z1, which is pi over 4, subtract the modulus of Z2, which is 2 pi over 3. So if you simplify that straight away, you know that if you divide the two complex numbers, you get another complex number which has modulus of half and argument of minus 5 twelfths pi.